Bismillahirrahmanirrahim. Welcome to Algebra 2. Chapter 1 in Algebra 2 is all about quadratic equations and functions. Now, much of what we do in this chapter, in fact, is a review of Algebra 1 concepts. The graph that you see before you, as you probably know, is a parabola. And in fact, this particular parabola is no ordinary parabola. This is the graph of the most basic of all quadratic functions or parabolic functions. Now, as I stated, a good part of what we do in this chapter is a review. So today what I'd like to do is, in fact, review some basic terms that we must know. We have a very simple objective today. Precisely, we want to understand what we mean by a quadratic equation and what we mean by a quadratic function. In other words, when I say we have a quadratic function, what does that actually mean? So our goal today is simply to understand what quadratic means and what's the difference between equations and functions, etc. The first term that I'd like to share with you is the term expression. Okay, I'll give you an example of an expression, negative 3x to the fifth. So this is an algebraic expression. It's basically a soup of some numbers and some alphabets to some exponents. It is some combination of numbers and variables and to some exponents, etc. When you add an equal sign to this, like negative 3x to the fifth, for example, equals 75, this is no longer an expression, this is an equation. So this would be an algebraic expression, and this would be an algebraic equation. How about this one? 4x minus 5 is greater than 16. What do you call this? Now, this is not an equation because there's no equal sign. This would be an inequality. How about this? Y equals 3x plus 5. Now this, of course, is an equation because there's an equal sign, but it's more than just an equation. This is a function because it relates x to y. It tells you what y is depending on what the value of x is. So here we have two variables, one that's dependent on another variable. This is an algebraic expression, this is an equation, this is an inequality, and this is a function. So now we can tell the difference between an equation and a function. Now I'm going to share with you some terms that are very useful to know right off the bat. Now when you have one term, such as negative 3x to the fifth, this is called a monomial, a single term expression. When you have two terms, such as x squared plus 4, this is a binomial. And when you have three terms, such as x squared minus 6x plus 7, this is a trinomial, three-term algebraic expression. And when you have more than these, such as the following, negative 7x to the fifth minus 4x to the fourth plus 3x cubed minus 7x squared plus 6x minus 37, that's simply a polynomial. In other words, many-term algebraic expression. So, a monomial is one-term expression, a binomial is two-term expression, a trinomial is three-term expression, and a polynomial is multiple-term expression. Okay, I'm going to present to you a polynomial. 4x to the seventh minus 5x to the sixth minus 3x to the fourth plus 11x squared plus x plus 9. This is definitely a polynomial. Now, there are some terms that are associated with polynomials that are very useful to know. First, I'd like to make an observation. If you notice that as I have written it, I have written the greatest exponent first. So this is x to the seventh and then x to the sixth. X to the fifth is missing, but that's okay. X to the fourth and then x to the third is missing, and then x to the second, and this is x to the first. And in fact, in general, it's considered good mathematical manners to write exponents in decreasing order. It's desirable or mustahab to write exponent in decreasing order like this. Notice here, x to the first, there's a 1 there, that's invisible, that is omitted. I also want to bring to attention that there are some terms that are missing. X to the fifth was missing, and again, x to the third was missing. Now, each of these, of course, is called a term. So in this polynomial, there are 6 terms. That's the first term, the second term, the third term, the fourth term, the fifth term, and the sixth term. And that's important because if you wanted to talk to somebody about polynomial, you say, in this polynomial, the fourth term, right? And you have to know what the fourth term is. And if the polynomial, as it should be, arranged in descending order of the exponent, both of you will know exactly which term you're talking about. That's this one here, the fourth term. Now the first term over here, it's given a name. It's called the leading term. That's appropriate enough. And the last term over here, if it's just a number like this, that's called the constant term. There's no variable associated with it, therefore it does not change. Because the value of the remainder of the terms, of course, will depend on what the value of x is. Now, if you look at an individual term, for example, like over here, the number before the variable, that's called the coefficient. So the coefficient of x to the sixth term is -5. And the coefficient of the leading term is 4. In fact, the coefficient of the leading term is given a special name. That's called the leading coefficient. Now, this one over here, the x term, this term over here, it has a coefficient too. And the coefficient is 1. It's invisible because 1 is usually not written. But it's there. Just like the exponent here was not written because it was assumed it's there. What we're doing here again is learning some terms that are associated with polynomials that are very useful to know as basic algebraic terms. Now, as I have already suggested, we like to arrange exponents in decreasing order. That's just plain good mathematical manners. It makes it easy for us to organize our work and communicate with others. Now, the exponent of the leading term right here, the 7 over here, is very important because it kind of gives the name to the polynomial. See, a polynomial is named after the exponent of the leading term. So the degree of a polynomial is the exponent of the leading term. In other words, this would be a 7th degree polynomial. So to review, we suggested this is a polynomial, that is a multiple term algebraic expression. And we said that this polynomial had 1, 2, 3, 4, 5, 6 terms. And we arranged them neatly in descending or decreasing order of exponents, the largest exponent first and gradually decreasing subsequently. We suggested the first term is called the leading term, and it has its own coefficient, the leading coefficient. The last term, if it's a number, is called the constant term. And we suggested that polynomials are named after their leading term. Whatever the greatest exponent is, it gives name to that polynomial. And in this case, this would be a 7th degree polynomial. Okay, so let me give you some more examples. How about this one? 4x to the 6th minus 6x cubed plus 4. Now this is a 6th degree polynomial. Now you can say this is a 6th degree trinomial. That's okay too. Now it's 6th degree because the highest exponent is 6. Now what's the leading coefficient? Well, the leading coefficient is the coefficient of the leading term. The leading coefficient would be 4. How many terms are there in this polynomial? Well, there are 3 terms. 1, 2, 3. Although there are 3 terms in this polynomial, this would be a 6th degree polynomial because polynomials are named after the highest exponent. In this case, it is 6. How about this one? X cubed minus 4x squared minus 6x plus 11. Now, there are 4 terms here, and this is a 3rd degree polynomial. And what's the constant term here? The constant term is 11. What's the leading coefficient? What's the leading coefficient? It's 1. Leading coefficient is the coefficient of the leading term. In this case, it's the invisible 1. How about this one? Well, this is a 2nd degree polynomial. Well, you can say it's a 2nd degree trinomial. That's okay too. But I like to say this is a 2nd degree polynomial because the highest exponent is 2. But you see, 2nd degree polynomials, or polynomials that have the highest exponents square like this, they're special because they're also known as quadratics. This is a quadratic expression. So now you understand that a quadratic expression is simply a 2nd degree polynomial expression. So here we have a 2nd degree polynomial expression, and we call that a quadratic expression. If I were to write this, x squared minus 4x plus 5 equals 13, see, now this would be a quadratic equation. Now, if I were to write this, y is equal to x squared minus 4x plus 5, this here would be a quadratic function. So if somebody were to ask you what is a quadratic equation, you should be able to express a quadratic equation is simply a second-degree polynomial equation. So now I hope you understand what this chapter is all about. It's about quadratic equations, and it's about quadratic functions like this. And as I've already suggested, if you were to graph out quadratic functions, they come out as parabolas. Today I shared with you some very important basic algebraic terms. Inshallah, we shall explore these in detail. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.